All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing some Rust studies. So recently, I decided to actually, it's been a while since I made the prompt, but like I've recently started actually, going through with it. I decided to relearn Rust, more specifically relearn the basics and then also move forward with learning more of the advanced things in Rust, but through Gemini instead of using the using any online documentation. So what I did is I asked Gemini to prepare a sort of syllabus for me and then divide that up into chapters and then load the chapters as I tell it to. So so far it's been going good. Okay. So to be fair, heading into this, I already knew the basics of Rust. So it was sort of a hold on, give me a second. Just a second. Okay. Sorry about that. So, um, what was I saying? Yeah, so heading into this, I already knew the basics of Rust, and I've already covered some of the more advanced topics as well. I've done a couple of small, like very tiny practice projects in Rust, so I do have some experience with it. But this time I wanted to kind of quote unquote go all the way in terms of learning. And then I kind of already have projects lined up. And among, well, aside from data science and machine learning, which I plan on doing that in Rust as well. I also plan on doing ESP32 programming in Rust because I feel like at this point now I would be able to. Um, what was I saying? Yeah, I feel like at this point, given my setup and given my workflow, I would be able to do ESP32 Rust programming pretty well, and it would also give me an excuse to do stuff in Rust. Oh, another projects that projects no another project that I have planned is the GameDev project that I was going to be working on. That's actually another reason why I'm relearning the basics of Rust and kind of relearning the advanced stuff in Rust as well. It's because I actually just remembered this that like this was what kind of sparked that whole thing that I want to relearn the basics before heading into it. It's that I'm planning on using a TUI framework called Ratatouille to build a game. I have some plans for stuff that I want to do, and yeah, that's kind of why I want to learn the basics of Rust again, relearn the basics of Rust before I jump into that framework because now I actually have a couple of projects in mind. I have a couple of use cases in mind to where I know that yes, I'm definitely going to be using Rust. I'm definitely going to be getting a lot more practice of Rust. Even if I don't do data science and what is it, machine learning and deep learning stuff in Rust, even if I only sparingly do AI and ML stuff in Rust, I would still be doing the other stuff in Rust. So embedded programming and game dev, and even the game dev thing, it's going to present its own challenge because Ratatouille is not a game dev framework; it's a TUI framework. But I'm going to be using it to build a game. So that should be interesting. Trying to solve all of the challenges that it presents, that should be an interesting experience. Give me a second. Let me get my background sound going, which is currently uh, probably going to be Iron Mouse's live stream because she's live right now. So give me a second and let me just get that going so that I don't have just silence around me, and then we can continue. So what I did is, because I'm having this conversation with Gemini and I'm having that conversation on another machine which is not really being captured by OBS, so I can't show it on stream. Because of that, what I decided to do is uh, each of these chapters, as we load new chapters, the text response that Gemini gives, I'll just copy that into an open NeoVim buffer, kind of like I have right now. So if you look in the right side of the screen, if you look at the right side of the right side of the screen, then you can see the text, and that's how you guys are going to see what I'm reading. I'm going to be looking at Gemini's response in the Gemini web interface, but I've pasted the text here so you guys can read it as well. Give me a second. Let me do what I was gonna do. Just a second. Another machine that I was working on, it is running kind of slow. So just a second while I try to make it not run slow. Man, I was supposed to start the stream like an hour ago. If I would have started an hour ago, I probably would have had more time to stream, but I'm just horrible with time management. It is what it is. Just a second, just a second. Okay, all right. So we are gonna jump into it. So we are currently on chapter 3, which is structs. Prior to this, we were looking into references and borrowing, which is another interesting concept. That's something specific to Rust, actually. That chapter teaches you about how Rust handles memory safety. It has a sort of borrowing system where you can either copy a value or you can move a value. And in terms of reading a value, you can temporarily borrow it to read stuff off of it, or you can mutably borrow it so that you can edit the thing. There's like certain rules that have been made up to make sure that you're able to do your programming in a way that is memory safe, um, while still giving you some control over, low level memory stuff. Not exactly low level, but like still giving you some control over memory stuff. Okay, so we're going to start reading chapter 3, which is Structs. So, theory and explanation. While tuples allow you to group related values, they don't give the values any semantic meaning. Accessing a tuple element like person.0 is not very descriptive. Structs, short for structures, let you create custom data types that group together related values and name them, making your code more readable and self-documenting. Okay, just a second. What I was going to be doing, I am able to do it now, so I'm going to do it. As in the background sound that I was going to be loading up, I'm able to do that now. Dude, I want to do so much more stuff in Rust, man. Yeah, cuz like I feel like I had a realization that I've been doing C sharp for more than a decade at this point. And the majority of the C sharp stuff that I was doing, I mean, I did do some other projects in C sharp, but the majority of the stuff that I was doing in C sharp was all Unity related. And outside of that, I wasn't really using C sharp for too many other things. Like I said, there were a few other things that I was using it for, but outside of Unity, there weren't too many other things that I was using it for. And now I feel like if we are talking about a more general purpose language, I feel like Rust might actually be a pretty decent choice because the interesting thing about Rust is that Rust is a language that it can be used as a general purpose programming language, but also as a systems programming language. Like the language itself is described as a systems programming language. So there's a whole lot of like low level stuff that gets done in Rust. However, Rust also provides you, there are libraries that you can use in Rust in order to make various high level things, or rather, I should say, there are various libraries that have been made in Rust that allow you to do high level things. So, by that logic, you could then use Rust to even just do general purpose programming solely because of how vast the ecosystem is, how many libraries and crates and stuff you have available to do stuff with. Like, take a look at deep learning, for example. You have two crates. I mean, there's multiple crates that you can use, but there are two crates that I've had my eyes on. One is Candle, and the other was. Give me a second. Let me look it up. I can't remember. There was Candle Rust. Minimalist. Oh, and the next one was Torch. So Torch was basically Rust bindings for the C++ Torch library. And then you have Candle, which is actually something maintained by developers at Hugging Face. This is a framework that you can use for deep learning related tasks. So you can build a neural network, you can train a neural network. I believe you can also run the neural network through it. So I mean, right there you have like a bunch of high level stuff that you're able to do. There's lots more examples of higher level stuff that you're able to do because of libraries that have been built in Rust, and because they're built in Rust, so like they're super fast. So kind of I'm kind of like I just had this realization that I'm not gonna forget C sharp like ever. I don't think so. Even though like I don't do much C sharp programming these days, C sharp is just one of those things that because I've done it for more than a decade, so I'm gonna remember it. Like, I'm just it, that's just the way it is. I've been doing Python for more than a decade, so I'm just gonna remember it. Rust is something that I'm still fairly new too. And so I kind of need as much practice as I can get in Rust so that I end up in a similar situation as C Sharp and Python, to where I could not touch Rust for a couple of months and then come back to it and still remember every single thing. Now, the interesting thing is, it's not necessarily the syntax that I cannot remember. It's various other things, various components, various behaviors, various stuff like Rust's memory safety system, concepts like the borrow checker, concepts like, or well, concepts like references and borrowing, concepts like lifetimes, stuff like how to handle asynchronous programming in Rust. These kinds of concepts, I kind of want them cemented in. I kind of want to solidify those concepts so that I'll remember them, even if I don't touch Rust for a couple of months. And the only way to do that is to actually do projects in Rust. Right. So, where was I? Okay. Um. Yeah. So there are three main types of structs. Classic structs. These are the most common. They have a name and named fields. Each field has a name and a type. This is what you'll use most of the time. Okay. Right. So that's what I'm looking at here. Let me just scroll. Wait a second. Yeah, I need to scroll here as well so that you guys can see it. All right, next we have tuple structs. Oh, see, this is another. This is a good example, I guess, of various things that I might forget if I don't touch Rust for a while, and I kind of want to make it so I don't forget it, even if I don't touch Rust for a couple of months. And dude, the interesting thing is Rust is like, I don't know, like Rust allows you to do so many different things. You are not limited to just low level stuff because of because of all the all the libraries that are provided. There's a fair bit of high level stuff that you can do in Rust. Now, how much easier it would be, or how much less complicated it would be to do something high level in Rust compared to doing something high level in C Sharp, I guess that would be something that I would have to find out, because I've done high level stuff in C Sharp. I've worked on projects in C Sharp. My current VTuber application is also something that's running in C Sharp. Um, and it's also actively being maintained through, dude, actually, okay, um speaking of my VTuber application, i I had a bunch of ideas for stuff that I wanted to do with my VTuber app, but I kind of feel like I never really got around to doing any of that stuff. I built an infrastructure, and I kind of always run into this issue where I'll build a bunch of systems. I'll build the infrastructure for situations where if I want to do extra stuff, then I would be able to do extra stuff. The issue is that I often end up not doing the extra stuff. So the extra hard work that I'm putting in, it becomes kind of useless. It kind of goes to waste. And instead of doing that, if I would minimize the scope, if I would have a fixed scope, if I would actually scope my programs and my projects properly, instead of making them more open to, um, you know, the ability to add features later on, if I kept the scope limited, then I probably would be accomplishing a lot more. Because I suffer from feature creep just as much as a lot of other developers do, and at least with my own projects, I tend to do this thing a lot where I'll be like, okay, I'm building this system, but what if in the future I want to do so and so thing? Okay, let me add a feature to be able to do that. Okay, what if I want to do so and so other thing? Okay, let me add a feature to be able to do that. Oh, I need to make this system scalable in the future if I want, which it's kind of it's kind of silly to think about. Like, imagine you're building a VTuber application that you and only you alone are going to be using, yet you decide to fill it with features that you could possibly use in the future, yet you decide to make it scalable. Scalable for what exactly? Like, even I don't know, but I would try to make it scalable. Like, that's just, at a certain point it just becomes dumb, and I've done dumb stuff like that. I'm still proud of it though, because it taught me a bunch of things. Like, actually doing those things taught me a lot. But in terms of practically using the things that I built, the features that I built, I haven't really done a whole lot of that. I've done quite a bit of that, but like, not all of the features that I built were actually used, if that makes sense. So like, at this point I'm wondering, hey, what if I tried a different approach? Because, okay, here's another thing, right? I have so recently VRChat brought their selfie expression feature into open beta, and they remove, actually I think it's been in open beta for a while, but recently they removed the restriction of it being VRC plus. So you don't need to have VRC plus in order to test out that feature. Selfie expression, for those of you who don't know, is basically, you can it's a feature that allows you to connect a webcam uh, to your computer or your laptop, and then that webcam can capture your head movements and your facial expressions and hand movements and stuff like that. It can basically do face and body tracking for you. It's more head and limited face tracking. So face tracking to a certain extent, and it can also do hand tracking. I don't know about hip tracking and leg tracking, but at least for the upper part of the body, it can do the tracking for you. So I recently connected my webcam that I was using on another machine. I connected that to this machine, and now I'm thinking, what if I decided to build something in Rust which is limited to literally only tracking my just tracking me. So so basically what I'm building is a puppeteering application. How I'm going to go about doing that, I don't know yet. I need to look into what my options are and what I want to do, because I have some ideas for stuff that I would definitely love to try out. Like, for example, um, what if I was able to run what if I captured my hand and head and body and all those movements and somehow translated that into terminal based artwork? So I rendered that using the terminal instead of 3D graphics. Like, imagine that. And I could take it a step further. Instead of showing a human form, I could show basically any other thing and kind of animated, basically how this model of mine is animated, but I could do that in Rust instead of doing it in Unity. Though I mean, that's not it's not It's not like what I've built in Unity is bad. It's just an idea. Like, what if I tried to do something like that? I could use various like body pose estimation models. I mean, I'm only going to be using one, but like I have options. I could use body pose estimation models and run them directly in Rust. Either I can export them to Onyx or I can find some other way to run them. Maybe through Torch, I might be able to run Python. Um, I might be able to run models that have been built in PyTorch. Dude, hold on. Yeah, wait, dude. I just realized, okay, I should try that. No, no, you know what? Yeah, no, I need to look into that because a lot of times when you have these kinds of frameworks, they usually provide a library to be able to use the the models. You're not generally directly interacting with the models, though you would be directly interacting if you tried to go on the lower level, but that requires a lot of understanding of the framework and stuff like that. But yeah, that is something that I could do. The funny thing is that that would be yet another rework of my VTuber model. Yet another rework. But I'm kind of excited by the idea of that, if I'm being honest. I don't mind like, you know, working on the thing in Unity, but I don't know. I had a bunch of ideas. I had a bunch of ideas for stuff that I could do, VTubing wise. Um, I didn't. I never really got around to doing all of those things. Yeah, there was uh, a huge inspiration for me was uh, there were multiple people, but one person that I can definitely say was a huge inspiration for me was Fofa, Fofamit. Um, I don't know if she's still. I think she does still stream. Like every now and then, she actually I haven't been keeping up with her streams. She probably still streams. But like go check her out. She does like amazing custom VTubing stuff, and she has a channel as well where she posts like tutorials and stuff about VTubing. Not just like not just stuff like, you know, setting up live 2D and getting a model up and running. No, she has gone like way beyond stuff like that, more complex stuff, like how to make a 3D model VTuber application ready, how to get a 3D model to the point where you are able to do body tracking and face tracking and all of that stuff. She was definitely a huge inspiration for me, and that was also like one of the reasons why I decided to rework my initial VTubing application into what it is right now. And one of the many ideas that I had back then, and this was a good like 2 3 years ago, I think, when I had started working on the application. It was I had ideas, dude, for like, you know, 3D environments and stuff that I wanted to set up in within the application. And now that I'm doing a bunch of other things on stream, now I kind of want to do different stuff in terms of VTubing. I don't have those same ideas that I want to go with. So it's more I'm very interested in setting up a very limited scope. Something that I do want to maintain, if it's going to be possible, is my I built. Let me show you guys. Hold on. I built a specification. I built my own like communication system Um, I built my own communication system within my VTuber app, and it's a communication system that I set up so that my VTuber application would be able to communicate with external apps. And yeah, I did actually end up using it. There's quite a bit of work that I put into it. Though if I reworked that right now, I would definitely do it in a much different way, because not everything requires a custom setup. Okay, you know what? I'm just yapping at this point. Um, let's continue with structs. We are learning about structs in Rust. Give me a second. I just want to do something here. Okay, so the next thing we are reading is tuple structs. So these are like named tuples. They have a name, but their fields are unnamed. Okay, they're useful when you want to give a tuple a distinct name and type, but the individual fields don't need their own names. Okay, so I'm guessing in that case you would be accessing them with like 0, 1, 2, etc. Then you have unit structs. These have a name but no fields. They are mostly used when you need a type to implement a certain trait, but you don't need any data within it. Okay, I never really thought about unit structs or unit like structs in that way, where you have to implement a type that you can then use, but you don't really have any data to implement on the type, or any data that you any fields that you want to implement within the type. Okay. Okay, so a key part of working with structs is defining methods. Methods are functions that are associated with a struct. They're defined within an impl block. Okay, yeah, yeah. This is implementing traits for a certain struct, and when you're implementing traits for a certain struct, if those traits have functions or methods within them, then you can implement those methods for this struct as well. Okay, they are defined within an impl block. The first parameter of a method is always self, which represents the instance of the struct the method is being called on. Which represents the instance of the struct the method is being called on. Okay. This self can be a plain self, which is taking ownership, or an immutable borrow self, or a mutable borrow self. Okay. Most of the time, you'll use a borrow, so you don't consume the struct instance. Okay, cool. So we are done with this. Now we are going to move on to the exercise program. Okay, so this program will create a simple rectangle struct and a method to calculate its area. This is a classic and clear example of how to use structs and methods effectively. The program will define a rectangle struct with width and height fields, use an impl block to define an area method, use an impl block to define an area method for the rectangle struct. Where was I? Yeah, use an impl block to define an area method for the rectangle struct, and then this method should take. Oh yeah, I just remembered. It's not You're not always implementing. You're not always using impl blocks for implementing traits. You could also just implement methods, like without having a trait on the thing. You could just implement, because like if you want to implement a trait for a struct, you can do that using an impl block. But you can also just implement methods for a struct, like your own custom methods. Traits, at least in this situation, would be used more like interfaces in C sharp, where you can define a sort of you can define an interface, and within that interface you can define various methods, and then you can implement that interface for a certain type, for a certain class. And so that way, any you can have like a fixed set of behaviors. You can use it to define a fixed set of behaviors. Okay, what's next? Oh yeah, okay. Use an impl block to define an area method for the rectangle struct. This method should take um, a self borrow, a self reference as its first parameter, and then in the main function you create an instance of the rectangle struct and call the area method using dot syntax and print result. Okay, so this is the code, and now I guess I'll implement it. Okay, so struct rectangle. In here we want width, which is going to be an unsigned, I'm guessing that's an unsigned 32-bit integer. Then height, which is also an unsigned 32-bit integer. Then we do impl rectangle. So I'm guessing this is how you mentioned that we are implementing methods for the rectangle struct. Okay, so it mentions this is a method. The self, the ampersand self parameter is an immutable borrow of the rectangle instance. Oh, so it's mainly just for reading purposes. Okay, so area ampersand self. Okay, u32 self dot width multiplied by self dot height. Great, so it returns that. Then okay, so this is a method because this is part of the instance. That's an important thing to keep in mind. There's a difference between instance methods and associated functions. So I'm guessing we are going to be looking at, yeah, okay, so the next thing is an associated function. It doesn't take the self parameter. It's like a static method in other languages. Yeah, there you go. In C sharp, this would be considered a static method where you don't need to create an instance of the class or the struct before being able to access. I actually don't remember if it works the same way in structs in C sharp. So I'm just going to say class because I've done this quite a bit with classes in C sharp. But yeah, this is where you don't need to create an instance of the class before being able to access the method. That's a static method. Okay, width u32, height also u32, and then this returns self. And then we call self with width and height. Okay, this is interesting because right. So I believe this. Oh, what did I just do? Yeah, I believe this is this entire line is the way to declare a struct. So for example, if I did let a equals, actually we could specify the type as well, rectangle, equals rectangle. I don't remember if this is exactly how it would be done. Hold on. Let's try this. Okay. 5 and 10. And let's save this and see if we get an error. Missing fields, width and height. So we need to name the fields. Width is this, it is 5, and then height is this, it is 10. Okay, cool. So this is how it works. And actually, I just remembered something. This formatting thing that just happened, I just remembered something that I learned about how to avoid doing this in Python. It's the trailing comma. Yeah, there you go. Okay, okay. So we're gonna try something here. Okay, just so I can remember. Uh, okay. Right. So what was the thing? Was it with a trailing comma or without a trailing comma that would cause this? I think it was okay. Let's put the trailing comma there so that it doesn't format. Hopefully it doesn't format. No. Okay. This is formatting it. What was the thing with the trailing comma? Oh, and did that only apply? So okay, this was to do with rough, I believe. Rough is a formatter, which in my case I was using it specifically for Python. Was I? I don't remember. Was that for Python or for Rust? No, it was for Python. Yeah, yeah, it was for Python. Because I had this issue where it would like let's say I defined a tensor. I'm gonna define it here in Rust and it's gonna show up as errors, but like that's fine. So let's say TO1 equals tensor. That's a method, right? And then I would do something like this, because within the tensor you have to give it like a list, and that list can be a list of lists. So just for the sake of being able to visualize it, I would format it in this way. So let's say 1 2 3, and then next line, um, 2 3 4, and then so on. But the problem is, what would end up happening is if I save the thing, I don't know if it's going to do the same thing here. If I would save this, it would kind of collapse the entire thing into one line. And I couldn't remember what was causing that. Was it, I think to avoid that, you would have to put in the trailing comma, because if you didn't put the trailing comma, then at least in this situation, the behavior would be to just just squeeze everything into one line. And you can also control the behavior for like, let's say if squeezing everything into one line exceeds a certain number of characters, then it's not going to squeeze, or it's going to squeeze in a different way. But like there's like certain um, things, certain specifics to keep in mind there. But yeah, this is what I was talking about earlier. Yes, I know this is an error. I don't know if rough is being used for Rust as well, or if the Rust analyzer is also doing this formatting stuff. Actually, I think we can find out. Hold on. Uh, Open up lazy. Here it's gonna mention. Okay, updates. Okay, okay. Okay. All right. Cool. Great. Yeah, I don't know what is being used for. Let's see if rough is loaded here. No, rough is not loaded. Okay, if it is loaded, then maybe I'm just not seeing it. But yeah, okay, I'm not sure if rough is being used here. So I can't say for sure. I don't want to give out wrong information. But yeah, okay, so back to this. So self, I need to look into the difference between this kind of self and the other kind of self, because the other one seems like a keyword. This is also a keyword, but like this kind of um this means something different. So I guess I can ask that question within here. Wait, after this is done, we need to look at the main function and oh, okay. Anyways, we have to create a new rectangle here. So okay, we have A is that, and then B can be rectangle new, and then in here we specify 10 and 20. I'm not sure why it added height here, but okay, great, awesome. Wait, what if I add a trailing comma here? It just removes it. Okay, never mind. Also, yeah, I think that formatting is being done by the Rust analyzer, or maybe one of the tools that's running as part of the Rust analyzer package. Okay. Um, right. The area of the first rectangle is so and so, and the area of the second rectangle is so and so. Let's do that. So we can get rid of this statement, and in place of that, we can do print line. Uh, the area of the first rect is this, so that can be a dot area, and then the area of the second rect is this, and then we can do b dot area. Okay, now we can run this. All right, there is our. Why does it look like that? That's confusing. Hold on. Why does it look like that? Yeah, I'm kind of confused about that. Why is it cut off? Hold on. I need to remember this. Yeah, that's what I'm looking for. So anytime I want to go to the beginning, I can do this and then run. Yeah, the whole thing seems cut off. I'm just realizing that this is the... Oh, oh. Wait, never mind. It's not cut off for you guys. It's cut off for me. It's kind of cut off for me. I wonder why that is. Yeah, that's this. So this whole thing is happening on a different machine. What if I restart the windowing system or refresh the windowing system? Okay, whatever. So we know that the thing works. Right, great. So, right, instructions. Save the code, compile it, run the executable. Okay. All right. So now I'm going to ask this question. So I noticed you used self in some places, but self in others. Explain the difference. Okay, so there's a bunch of text here. So let me just copy the thing and type it out for you guys here so you guys can see. Just a second. Okay. Okay. That should be it. Right. Okay. Moving back here. Wait, why does it only say the cap? Oh, wait, there's quite a bit of text. Which is great. I mean, there's more for me to read, basically. Okay. All right. Okay, so the self and self keywords are both related to the current type or instance, but they serve different purposes based on their capitalization. So self in lowercase is this keyword refers to a specific instance of a struct or enum. Enum is also something that we need to get into next. I think that might be the next chapter. I'm not sure. Refers to a specific instance of a struct or enum. It is always the first parameter in a method's signature. Just a second. Okay, where was I? Yeah, it is always the first parameter. Wait, okay, hold on. The lowercase self keyword refers to a specific instance of a struct or enum. It is always the first parameter in a method's signature. It refers to the specific instance. Okay. It's an instance of the type. It's an instance of the type that the method is called on. All right. There are there are three common forms: self, ampersand self, and ampersand mute self. So there's a self borrow and then a mutable self borrow. Okay. Self takes ownership of the instance. The instance is consumed and cannot be used after that method call. This is rare and usually only for methods like toString. Then borrow self borrows the instance immutably. This is the most common form used when you only need to read data from the instance. Sorry, zoned out. When you only need to read data from the instance, you can call the method multiple times without consuming the value. That's an important thing to keep in mind. With Rust, I feel like that's an important thing to keep in mind. The difference between something that could consume the instance versus something that's just borrowing the instance to read, versus something that's borrowing the instance um, to modify it, but it's still borrowing. It's not consuming. All right, then mutable self borrow, it borrows the instance mutably. This is used when you need to modify the instance in place. Something else that I feel like I need to remember, and Gemini had mentioned this. This was one of the things where I would get confused, like initially back when I was new to Rust and learning about the whole, borrow checker and memory safety and stuff like that. I feel like I had a hard time remembering this thing. Like there's a fix that, oh my God, Aethel is just screaming his lungs out. Okay, yeah. What was I saying? Shit, I forgot what. Yeah, so there's like certain rules that I feel like if I remember them, then I'm gonna be able to structure my code much better. So in terms of borrowing, you can either have a mutable borrow or an immutable borrow. You can have multiple immutable borrows, but you can only have one mutable borrow. That's something important to keep in mind. You can only have one mutable borrow, but multiple immutable borrows. So you can read as many times as you want, but in terms of modifying the thing, at any given time, there can only be one mutable reference. I feel like I had this issue in the past with certain, like once you go into using higher level types, sometimes you'll run into this issue. But like if you remember these rules and you're paying attention to the types that you're working with, because IntelliSense will quite often, reveal that, hey, this is the type, and it's either um, it either consumes or it borrows or it mutably borrows or whatever. All of these things are mentioned as long as you have IntelliSense, which, fortunately I do have it here in NeoVim. So we should be good. Okay, then comes self capitalized. So the capitalized self keyword refers to the current type itself. It's a type alias for the type defined in the impl block. You use self when you are defining a method that returns a new instance of the same type, often in associated functions like constructors. Oh, the new method, constructor, yeah. I completely forgot that that's what these things are called, constructors. Last time I used the concept of a constructor was in C sharp when when working with classes, because you can um, you can define a constructor. You can define multiple constructors for a type, for a class. So that way you can when you're instantiating the class, then you can specify different types of arguments, different types of parameters to initialize the class instance with. Okay, so self in that case is a type alias, does that mean, wait, so it says in the new function, self is a placeholder for rectangle. So self is the equivalent to rectangle. That's what I was about to ask just now. Would it be the same as um, rectangle? I'm not seeing any errors here, so I think we should be fine, right? Um, yeah, we should be fine. Great. All right, awesome. We are done with this chapter as well. Yeah, we are done with this chapter. We did structs. Actually, yeah, okay, hold on. Let's create a struct. Let's create a tuple struct. So let's do struct color, and then we can do I32, I32, I32. And just for the heck of it, we can also do struct. Um, dude, okay, would I then be able to implement methods for this struct as well? So impl color, let's say, I don't know, some O1. I always have a hard time with these names. Okay, self, all right, and then print line. We'll do this. And we are passing in self, right? So if I'm accessing that, would I need to access it in this way? No, I can still do it in this way. Okay. Oh, that's interesting. So we specified this as a reference, right? But then we don't need to do this. Okay, I need to ask that question as well. Okay, I also noticed that in the area function, you specified ampersand self. However, within the function, when trying to use self, you just used self, not ampersand self. Let's see what it says. That's an excellent and very subtle observation. What you're seeing is Rust's syntactic sugar for method calls, which makes the language much more ergonomic. The key thing to remember is that within the area function, self is indeed a reference. The ampersand in the function signature makes it clear that we are borrowing. Hold on, is there more text here? Well, I can post it here so you guys will be able to. Well, I mean, no, it's small. It's not worth it. Um, the ampersand in the signature makes it clear that we are borrowing the instance, not taking ownership. Implicit dereferencing. Okay. The reason you don't the reason you don't need to write so and so and so is because Rust automatically dereferences self for you. When you use the dot operator to access a method or a field, Rust automatically adds the necessary ampersand or so and so or asterisk to match the signature of the method being called. Think of it this way. Uh, when you when you write rect.area, the compiler sees the area's first parameter is ampersand self, and it automatically rewrites your call to this to give the method the correct type of reference. Inside the area method, when you write self.width, wait, that's interesting. Why is that happening though? Yeah, okay. You guys need to be able to see what is being said here because it's talking about how implicitly stuff is being done. Uh, so here I am in this section, implicit dereferencing. Okay, so what it's saying is that apparently when you call, let's say this a dot area, what it's really doing is this. Like, does that even work? Oh, I didn't finish doing what I was doing here. Uh, self dot zero, self dot one, self dot two. Are we good? I think we are good. Yeah. Okay, so implicitly what it's doing is this. I need to remember this thing as well. Like being able to jump to different. Dude, I wish Windows Terminal had um what do you call it? I wish Windows Terminal had what am I trying to say? Trails, cursor trails. Uh like this. Um you see this? Stuff like this. I wish Windows Terminal had this because this looks really cool. And I'm seeing this whole zooming thing happening whenever I'm coding, whenever I'm doing the Rust coding. But then you guys are seeing the Windows Terminal version of the Tmux session, if that makes sense. Like the Windows Terminal is what's rendering what you guys are seeing. But for me, it's the Kitty terminal that's rendering what I'm seeing on another machine. But yeah, anyways, where was I? Yeah, so apparently it's doing this implicitly, which I had no idea that it's doing that. Yeah, no, we need to discuss this more. Inside the area method, when you write self.width, the compiler sees that self is a reference. Okay, it automatically dereferences it for you to get to the rectangle structs fields, effectively treating self.width as self. That's crazy. Hold on. Wait, 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 hold on. I'm confused. I had no idea that when I do rect.area, it is actually doing uh, rect.area. What? Yeah, dude. I even when I was learning Rust, I had no idea that it was doing this. Like even when I was learning Rust from the docs. I had no idea that it was doing this. Wait, okay. Internet issues. Are we about to crash? Hopefully not. Hopefully not. Okay, where was I? Yeah, I had no idea I was doing this. Dude, something else that I need to learn. I just remembered that. Something else I need to dive deeper into with Rust is um what was it called? Unsafe code. I need to look into unsafe code as well. Unsafe code and stuff like raw pointers and various other things. Like more, these are much more advanced concepts. I don't want to touch any of the. I did touch them a little bit in the past, but like I didn't go too deep into those topics. Just kind of scraping the surface to get some understanding of what's going on, and I didn't really get a chance to go too deep into it. Wait, give me a second here. There's no P, so it's definitely just A. Jump to the bottom edge of the scope. What is the bottom edge of the scope? Okay, I guess in a specific line, scope here is the function. Okay, I can look into that later. Yeah, I need to remember this thing because this can help me jump around much more easily as opposed to using this. Yeah. Okay, right. That's a completely normal reaction. This is one of Rust's more magical features. Just a second. I need to make sure my system is all right. Hold on just a second now. Why are we consuming so much? No, okay, we're good. We're good. Right. Okay, so we have some text here. Let me just copy this over on this side so you guys can read it as well. Okay, so this is where we are at. Okay, that's a completely normal reaction. Um, this is one of Rust's more magical features if you're coming from a language where you have to be explicit about everything. You're not confused, you're just discovering a core part of Rust's ergonomic design. You're correct when you do rect.area. I kind of feel like this might be one of those things similar to how Rust's lifetime syntax, or I think it was the generics syntax, kind of evolved over time. So now you actually have syntactical sugar for it, but like in the past, you had to do a more verbose version of it. I can't remember if it was the lifetime syntax or if it was the generic syntax. But yeah, I'm gonna have to look into it. Dude, I feel like I need to do more projects in Rust, man, because the only way that I'm going to explore and understand this language on a deeper level is if I start doing the same, if I start doing projects in it just as heavily as I was doing in C sharp, because that's the reason why I learned C sharp. Or, well, that's not the reason why I learned C sharp in the first place, but that's the reason that I got good at C sharp, because I was doing a lot of stuff using C sharp. I need to work on a bunch of Rust projects. My own little Rust projects, but still Rust projects. Okay, where was I? Okay, you are correct. When you do rect.area, the compiler is indeed automatically doing a reference behind the scenes. The smart dot operator. The dot operator in Rust is not just a field accessor, it's a smart operator that automatically handles referencing and dereferencing for method calls. It works it works like this. When you call a method like rect.area, the compiler looks at the method's signature. Just a second. Okay, where was I? Yeah, when you call a method like rect.area, the compiler looks at the method's signature. Um, the signature for area is so and so. Okay. The ampersand self tells the compiler this method needs a reference to a rectangle. Okay. All right. The compiler then looks at rect. Since rect is a rectangle instance, not a reference, the compiler knows there's a mismatch. Oh, okay. To fix this, the compiler automatically inserts an immutable reference for you, turning your call into so and so. Just a second. Let me scroll down so you guys can continue reading along with me. Okay. To fix this, the compiler automatically inserts an immutable reference for you, turning your call into so and so. It's a form of implicit referencing. This behavior is mirrored inside the method itself. As we discussed, when you write self.width inside the area method, the compiler knows that self is a reference and automatically dereferences it to get to the width field. This is implicit dereferencing. De- this is hold on words. This is implicit dereferencing. The ultimate goal of this is to make your code cleaner and more readable. You can just use the simple dot syntax, and the compiler handles the complexity of matching references and dereferences for you, all while enforcing its strict ownership and borrowing rules. It's a perfect example of Rust prioritizing both safety and developer convenience. That is true. Yeah, I was just thinking about this while reading this, that imagine if I had to where am I? Here. Imagine if I had to type it out like this each time. Ampersand this and then width. That would be tedious as hell. Like that is no. That is just no. Um yeah, yeah. Okay, cool. So I just learned something. There's something else. Yeah, okay, hold on. Um, there's another thing I'm confused about. So when a method takes ampersand self, that means ampersand type name should be the one calling the method. Okay, give it a second because I feel like system's got a bit of a load here. Okay, I feel like this is, yeah, just give it a sec. Now, you know what? I need to quit this and open it up again, just at the off chance that it ends up heating up the CPU again. Give me a second. I'm doing something in the background, so just hold on. Okay, that's done. Now let's open this up. Okay. No, that's a very logical confusion, but that's not how it works in Rust due to the implicit referencing we just discussed. You should call the method on the struct instance itself, not on a reference to it. The compiler automatically inserts the ampersand for you to match the method's signature. The correct way to think about it is the variable rect is the rectangle instance. The method area is defined on the rectangle type and takes a reference to self. Wait, the method area is defined on the rectangle type and takes a reference to self. When you write rect.area, the compiler sees this and says the area method needs ampersand self. I will automatically give it a reference to rect. That's a good way to think about it, yeah. Because I feel like I'm looking too deep into this, and just I'm gonna end up confusing myself or just wasting time. Because like, yeah, in the past it was enough for me to understand that, yeah, self is a reference to, or no, self is the instance. Self is referring to the instance. We could have a reference to self. We could also have a mutable reference to self. That is enough to understand. So, okay, continuing reading. So you call the method on the instance, and the compiler handles the borrowing for you. This is a core design choice to make method calls feel consistent and intuitive. Okay. All right. So going back to the self versus, uh, just a second, versus self. So self is the instance of the type, and self is an alias for the type name, for the type name. Yes, that's a perfect summary. Self is a variable that represents a specific instance of the type. It's the receiver of a method call. And the capitalized self is a type alias for the type itself within an impl block. I feel like that's important to remember. You can use self to interact with data of a particular instance, and you can use self to, well, capitalize self to refer to the struct's type when, for example, creating a new instance within an associated function. Um, okay, so self can only be used in impl, or are there other situations? I'm sure there are other situations, probably more advanced ones. Um, or I guess not. Yes, you're correct. Self is a type. Self is a special type alias that can only be used within an impl block or a trait definition. Okay. So apparently even in traits it can be used. I need to keep this in mind because I do see self, well, the capitalized self popping up in trait definitions. Okay, when you're inside an impl block for a struct like impl rectangle, the compiler automatically understands that self is just another way of writing rectangle. That's a dude. Okay, okay. That's a This is good because sometimes type names can be long, so being able to just type self is going to be it makes it less of a it makes it less verbose. Let's say that. Similarly, when you define a trait, then self is a placeholder for the type that will eventually implement that trait. Oh, that's actually a pretty good, yeah, yeah, definitely. That's a pretty decent use case. So you can think of self as a convenient way to refer to the current type, but its scope is strictly limited to the impl and trait contexts. Okay. Um, where was I? Here. So I was gonna do this whole thing. Right. So in the case of a struct color, or in the case of a tuple struct, I think it's called. Yeah. In the case of a tuple struct, this is how you would access the members. And then in the case of a unit struct, you don't have members. So, okay, we can just say some struct O1, and then we can implement um, a method for it. So we can say fn sum O1 at self, so that this can be called on the instance. And then here we'll just uh, say sum O1 called from, uh, wait, I wonder what would happen if I did this. Yeah, I wonder if I can do, because this is an alias, right? Would this expand to that? Is there a name thing here? I don't see a name thing here. Yeah, I wonder if this would expand to that. Now, what's the error? Some struct doesn't implement so and so. Oh, okay. I need to implement something to, or I could make it a debug thing. Can I? The trait display is not implemented for so and so in format strings. You may you may be able to use this. Okay, let's try that. Yeah, I remember this being a thing. Like when you're trying to get something to display through print, then there's certain things you might need to implement. Let's see if this works. Um, Debug is not implemented. Okay, let's implement it, I guess. Though if I add the debug thing, oh, okay, all right, cool, great. So C equals color, and I don't know, let's do 255. I don't know, let's do magenta. Not like it makes a difference. C dot sum O1. Wait, that's the wrong sum. C dot. That's actually something we need to look into as well, because sum is a part of the option. I think it's a struct or an enum. I forgot what it is, but that's something that gets used as well. It's sum or none, so it's useful in situations where like you want to specify that it's either there is a value or there isn't a value, and you'll find a bunch of um, functions that either return an option or accept an option in some way. Okay, then D equals some struct O1. I should probably not use sum because sum will then later on become confusing for me. Okay, D dot, hold on, some struct, okay, some struct O1, all right. I think it's in this way because there's no constructor. Oh, that's something to keep in mind, I guess. All right, and then some. Okay, cool. All right. So this is our, I think one of them I set it to be print, not print line. Yeah, that was probably the issue. Okay. All right, so we have the RGB thing, and then we have some struct called from. Yeah, okay, so it expanded the name. Good to know. That's good to know for the future, mainly for debugging purposes. And then we have all of the other stuff. Great. Awesome. Cool. All right. Cool. So now I think I'm ready to move on to the next chapter. However, we need to do something first because I am out of time. Unfortunately, I started late. That is completely on me. But yeah, I did start late and I'm out of time. So give me a second here while I. Okay, you know what? No. Let's not do that then, I guess, because it's verified only chat. Um, Give me a second. Excuse the silence. Just give me a second. I'm looking for. Wait, this looks interesting. I don't know what this person is doing, but their setup and everything looks. And it is verified accounts only. Okay, cool. I guess we are not doing that then. Um, and this one is follower only. So I guess we are not doing that either. What is going on, dude? Dude, I feel like I've rated this person before. Adi Gal. I remember this name from somewhere. I feel like I've rated this person before. Okay. Yeah, let's go to this person. Where's my stream manager? Here it is. Okay. Okay, raid this person. I I remember this name from somewhere, but I just cannot remember. Like I'm pretty sure I rated the person before, but like I can't remember. But yeah, okay. So that's gonna be it for today's stream. I've actually been tempted to start up the mute streams again, at least until I've fully finished learning the basics of Rust and am able to start working on my um, VTuber voice app. What was it called? Stream AI voice app thing. Because that's going to be like a mix of Python and Rust. I need to sit down and like write down all of these. I do have them written down, but I think I have like quite a few things written down. I need to get like a proper. I need to set a proper trajectory, if that makes sense. Like I'm gonna do this and that and that and that and that. But yeah, okay. Anyways, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.